Welcome to Law & Order Statistical Victims Unit, Episode 2, Sampling Methodology. In the original research system, statistically based investigations are considered especially heinous. In Houston, Texas, the dedicated scholars who investigate these vicious problems are members of an elite squad known as the Statistical Victims Unit, aka DSP. These are their stories. Alright. So today we're going to talk about sampling methodology. So basically what we're talking about are populations and choosing samples from those populations. So what is a population? The population is going to be the collection of all individuals of interest. So for each one of you, for your research, you're going to have different populations. It could be U.S. citizens over the age of 18, lab rats, presidential speeches, corn plants, just whatever the whole population that you want to be able to generalize your results to, that is exactly who your population is. A lot of times the population itself is not something that we have an individual listing of all the members, so we have to use the sampling frame, and that's going to be the closest approximation of the whole population. So for example, the list of registered voters in Harris County would be the likely sampling frame for the population of Harris County voters. Okay, so the population of interest is Harris County voters. We don't have a list, especially a list of all voters for some future election. So what we do is we approximate that population with the list of registered voters. So the sampling frame is what connects our population, which is kind of theoretical in nature, to our sample. Okay, we've got our population, sampling frame mirrors it, and then the sample should hopefully be a representative subgroup of the sampling frame. So what is the sample? The sample is just a subset of the population. The sampling is the process by which a sample is chosen. So as you can see here, a sample of little n ants is chosen from a population of big N ants. Sampling is how we actually get that little subgroup, how that subgroup is selected. The goal from sampling is to get a sample that is representative of the population, a sample without bias. Okay, here we have two guys sampling a recipe. Had they just put everything in the giant pot without stirring, then they're not going to get a representative sample of the whole population of ingredients. Okay, they have to stir it up and then use their ladle to get a sample out to taste it to get a good representation of what the whole population is. If they didn't stir, whatever the last ingredient was that they put in there, that's what their sample is going to taste like, and it's going to seem weird. They're going to think their recipe is wrong, and that's not it. It's just that they had a biased sampling method. And so their response to making sure that they get a representative sample is to stir the pot. And we like to think of that stirring the pot as the same thing as randomizing, using randomization in statistical sampling. So we use random sampling whenever possible. Any sampling process in which the members of the sample are chosen by chance. The use of chance, whether you actually take all the individuals, mix them up, and randomly select them, or if you use you number all the individuals and you let a random number generator do the randomization, or if you roll dice to conduct the randomization. All of those things are what we do to stir the pot, to make sure that our sample is representative of our population. Okay, simple random sample is what we would do in an ideal world most of the time, unless there's a little bit of tweaking that can be done, which we'll talk about in a second, to actually optimize which types of groups we get. But simple random sample is any sampling method, random sampling method, in which every individual has an equal chance of being chosen, and every sample of size n has an equal chance of being chosen. So think of drawing names from a hat. That's the quintessential random sample. You write the name or some sort of serial number or identification sequence for each individual that's in the population on identical pieces of paper. They all get put into a big hat. They're thoroughly stirred, and then without looking, somebody reaches in, draws out an individual, and that individual becomes part of the sample. And then they mix up all the names in the hat again and reach in and pull out another name, and that person becomes part, or person or rat or plant, that individual becomes part of the sample until you get the sample. We use little n typically to represent sample size. Whatever n is for us, we're going to require that you have at least 40 or 50, and we'll make that decision here soon, individuals in your sample. And so you would select until you get that many individuals. Now, what would be great, you probably want to choose more. You may even want to choose up to like 100 people to include in your sample, because you can't force people to respond. Okay, stratified sample. A sample for which the population is divided into subgroups based upon a classification variable for which the researcher believes there will be a differential response. If you think back to the simple random sample, any sample of size n, it has an equal chance of being chosen. So that means, like, if we were doing a simple random sample of students from Houston Christian, we write everybody's name, put them in a hat, draw out the names. It is theoretically possible to end up with samples of all male students. Well, let's suppose we think that males and females are going to have different opinions, say, I don't know, on the uniform. Okay, maybe one gender is happy with the current uniform, and the other gender has a different opinion, is not happy with the current uniform. Then you would want to make sure that you have representative samples from both genders. Okay, you would want either, if you're doing a sample of size 50, 25 girls and 25 boys, or if you wanted to do a different type of stratified sampling, you'd still do the girls and boys, and you'd make sure that whatever percent of the student body is girls, that percent of the sample is girls, and whatever percent is boys, that percent of the sample is boys. And we'll talk about that a little bit more in a minute. But once you have your two strata, okay, so here's all of Houston Christian, here's all the guys, here's all the girls. Within those strata, you conduct random sampling. So you'd have all the names of the guys in one hat, all the names of the girls in the other hat, and you'd randomly select your guys, and you'd randomly select your girls. So basically, you're taking the population and dividing it up kind of into two separate populations based on, and I don't even like populations, two separate groups based on a characteristic that is knowable about all the individuals and that they bring to the situation. Okay, so like I said, there's two ways that you can then decide how many, for in our example, guys and how many girls you're going to choose. So you could go with 25 and 25, or which would be non-proportional stratified sampling, or you can do proportional stratified sampling. So if the school is 30% guys, you would make sure that 30% of your sample are guys, and 70% girls, you'd make sure that 70% of your sample are girls. Okay, so that's proportional stratified sampling. The sample mirrors the percentage of the subgroups in the population. Non-proportional stratified sampling, and the sample does not mirror the percentage of the subgroups in the population. In our previous example, it would be 25 guys, 25 girls. People tend to be real happy with those and think they're fair, even if that doesn't reflect the proportion of representation. So for another example here, if we stratified across grade level classification at Houston Christian and selected 25 students from each class to have a sample of 100, the grade levels would have equal representation, not proportional representation, because typically freshman class is the largest and senior class is the smallest, and the other two are somewhere in between. Cluster sample. A sample for which the population is divided up into clusters, which are different from strata. Strata, everybody's the same according to some variable. For clusters, the clusters themselves are representative groups of the whole population. And a simple random sample of the clusters is taken, and then a census of the chosen clusters is conducted. Finally, convenience sample. Now, this is our first sample that is not a type of random sample. Any sample that is selected without the use of chance for the convenience of the researcher is a convenience sample. Frequently, a group that is easy to access is used. So here we have a picture of somebody interviewing someone that they just come in contact with. That would be a convenient sample. All right, the great aspects of a convenient sample: it is convenient and it is doable. Okay, for y'all, it's going to be really hard for y'all to get a sampling frame from which you can do a random sample or a stratified random sample or a cluster sample. For most of you, you are going to have to do a convenient sample. It's doable. Okay, it's something that, given our resources, can be done. The not so great aspects of a convenient sample: one is that the group solicited may not be representative of the target population. This means that there will need to be an adjustment to the population to which the results are generalized. You might want to be able to generalize it to American adults in general, but if every member of your sample is from Houston or from Texas, with the vast majority being from Houston, then you're only going to be able to generalize to a Houston population. Another scenario is that sometimes the most convenient sample to take is a voluntary response sample. This occurs when a widespread invitation is offered to anyone who wishes to participate. So if you send out like a big open call on Facebook, or just if you put something on the announcements and ask people to voluntarily contact you with their opinion, then that is going to be a voluntary response sample. So when individuals select themselves to participate, here's the issue. Frequently, those with strong negative opinions are more likely to volunteer. Thus, the sample will overrepresent those with strong negative opinions. So you're going to get a lot of grouches, usually. Somebody that really has a complaint about a particular issue, or all issues in general. Those are going to be the people who are more likely to take the time, especially if it involves contacting the person conducting the survey, phoning it in, anything along those lines. So those are some of the not so great aspects of a convenient sample. This issue in number 2, that's an example of where you can end up with biased results, because the people with the strong negative opinions on any topic have, by definition, they're differing views than the population in general. Your sample is not going to be representative because it's not going to represent the people who have more neutral opinions, and maybe even those with strong positive opinions, as in proportion to how they actually exist in the population. So these are things you need to think about. Your next step in research is to decide what your population is. It would be great if you could come up with a potential sampling frame. That would be good to do right now. And then to think about sampling methods. Okay, if you can come up with a way to do a simple random sample, stratified sample, cluster sample. Let me go back to the cluster sample just for a second. I didn't really go over this little example with it. Here, these streets would be randomly selected, okay, from all the streets in a city, with the assumption that streets would be representative samples of the overall city population, and then every member on the street would be interviewed, would be surveyed. And so that is convenient, but because randomization is used, it is not considered a convenient sample. And sometimes people get confused with that because they're like, well, that's kind of convenient. Yeah, but chance was used in selecting the different streets. Okay, so think about what you can do, and Ms. Stewart will let you know when you need to get the population, the potential sampling frame. Remember, that's the physical list of the population you want to represent, and then the sampling method you wish to use. Okay, she'll let you know when you need to get that emailed to me and to her. Okay? All right, if you have any questions, please let me know. Thanks. Have a good day.